In Creo Parametric, you can add flexibility to any component that has already been placed in an assembly. Many designs contain flexible components, such as springs, clips, rubber washers, and so on. In this assembly, we have a plastic water nozzle. Traveling through a flexible foam housing, and then the flexible upper foam housing fits over both, fitting snugly to the lower housing. However, we can see from this cross-section view that there is interference when the components are assembled. There's interference between the nozzle and the lower housing, and the lower and upper housing. To add flexibility to the lower housing, select it, right-click, and select Make Flexible from the pop-up menu. Select the hole at the center of the housing, which we're going to want to expand in the assembled condition so that the nozzle can fit through it. Select the hole's diameter and then add it to the varied dimensions list. The diameter of the hole is 12, but we'll enter a new flexible diameter of 9, even though we know that we actually want the thickness to decrease in the assembled condition. A quick look at the cross-section makes it clear that we flexed the upper housing in the wrong direction, but it's easy to fix. Just edit the definition of the upper housing. In the dashboard, open the Flexibility tab and select Varied Items. Edit the flexible value back to 7 and complete the operation. There. Now the interference between the components has been completely removed. Even if your assembled components don't have any predefined flexibility, Creo Parametric makes it easy to add it on the fly, making adjustments later in the design process quick and painless. Did you know that sheet metal models can be formed using punches in Creo Parametric? A form is a shape in your sheet metal part that is molded by another part. A form feature is created by merging the geometry of a reference part to the sheet metal part. To place a punch form feature, click Punch Form from the Form Type drop-down menu in the Engineering group. In the dashboard, click Open so that you can select the part that will be used as the tool to create the form. In this case, select the louver form part. A form part is positioned on the sheet metal part using either assembly constraints or an on-surface coordinate system. This louver form part uses an on-surface coordinate system for its placement. Query to place this form on the inside surface of the sheet metal part. Then use the green offset reference drag handles to position the part on that surface. If you need to rotate the form, open the Placement tab and enable Add Rotation about the first axis. Since we're making a louver, we want a surface to be left open. So open the Options tab and activate the Excluded Punch Model Surfaces collector. Then select this surface to be excluded. Before completing the feature, notice that this form is being placed using the Dependent Merge option. This means that in order to change the shape of the form, you'll need to change the louver form part model. If you needed or wanted to edit the sheet metal part independently from the form, it can be placed using the Independent Inheritance option, which would add the features and dimensions of the form part to the sheet metal part. After completing the feature, you can see in the model tree that the features of the form have been added to the sheet metal part. Let's start the Punch Form tool again, and this time we'll place a form named Gusset Form using assembly constraints that are predefined in the form as a component interface. To position this form part, select this surface, the top surface, and this surface as an offset reference. Preview the feature and notice that there are no rounds where the form meets the sheet metal. Open the Options tab and enable Placement Edges. Then preview the feature again and notice that rounds have been added. Also notice that this form is going to be placed using the Dependent Merge option. This means that in the model tree, we won't see features that make the form. To edit this feature to be edited. Creo Parametric makes it easy to more accurately simulate your manufacturing process with flexible punch forms that can be added to your sheet metal models. Tool and select the sketch plane. That's it. 2 clicks and you're ready to start sketching. Notice that the Sketcher tab has opened, containing all the Sketcher tools required to complete a sketch, and that Creo Parametric starts the sketch in a 3D orientation. In this example, we're going to create a part that looks like this. Alright, start with a circle and use some lines to sketch a slot on the right side. After 2 pieces of the circle are trimmed away to create a closed loop, you'll notice that Creo Parametric controlling the dimensions of a sketch is simple. Let's make the gap here 60 and the size of the arc controlled by a diameter dimension of 120. Once the sketch is complete, close the Sketch tab by right-clicking and selecting OK in the pop-up menu or by clicking OK in the dashboard. Earlier, we entered the Sketcher by starting the Extrude tool and selecting a sketch plane. You can also do the reverse. This time we'll select the sketch plane and then start the Extrude tool. Select the front datum plane as the sketch plane and then start the Extrude tool. Regardless of your approach, after just 2 clicks, you're ready to begin sketching. Sometimes it's convenient to sketch in a 2D orientation. To do that, click Sketch View from the Graphics toolbar. Remember, when you enter Sketcher, Creo Parametric doesn't ask you how you want your sketch oriented. It just guesses. Most of the time, this is perfectly adequate, but sometimes you might want to change the orientation by right-clicking and selecting Section Orientation, Set Vertical Reference, and then select an edge to be vertical. In our case, we want the open end of the feature to be facing down, so we're going to right-click and select Section Orientation, Flip Section Orientation. There, now we can continue sketching. To complete the shape we're after, we need to add a rectangle that references both vertical edges of the slot. Notice, though, that only one of them has a reference created on it. The good news is that in Creo Parametric, you don't have to cancel the rectangle and open the References dialog box. Just use the Alt key and create and use references on the fly, while continuing to sketch. Notice now that a reference line was created and the rectangle now snaps to it. We need the bottom of this rectangle to snap to the edge of this arc, so we'll create a reference there too, the same way. On the fly, press Alt and select the arc. Now the rectangle can snap to the intersection of the arc and vertical references. And there's our sketch. The new Sketcher workflow makes sketching and reference selection much more intuitive, and it can be a powerful time saver in your design process. When you're working with cylindrical sheet metal designs, you're almost certainly going to be using the Revolve tool to create the primary wall feature in your model. A revolved wall is created by rotating a sketched shape about an axis, providing you with a surface to which a sheet metal thickness can be added to either the inside or the outside. To start our sketch, let's select Datum Plane Front as the sketch plane, and then start the Revolve tool from the Shapes group drop-down menu. We're going to quickly turn off datums so we can see what's happening more clearly. Now that Sketcher has been started, sketch a center line that the shape will be revolved about. After sketching the center line, right-click and select Axis of Revolution from the pop-up menu to tell Creo Parametric which axis the sketch will be revolved about. The next step is to sketch the shape that will be revolved about the center line, and Creo Parametric will immediately display a preview of the revolved sketch. Edit the material's direction can be toggled between inside and outside of the sketch. The next time you're working with a cylindrical sheet metal design, try revolving the prime rate way to get your design started.
So you just mentioned that you want to learn Python. So do not learn Python in manual way in 2025. Because learning Python in manual way will take you.
Legacy Migration Extension. Step 3. Drawing value. That we have a drawing with solid views, associative dimensions, and attached notes on top of the original CGM or plot file coming from the originating CAD system. We first create a plot file using a